Hi everyone, and welcome to Algebra 2 Lesson 6-7, Investigating Graphs of Polynomial Functions. This is Part 2, Graphing a Polynomial Function. So we're going to look at how to graph a polynomial function, then we're going to look at some term words related to those graphs. So first, let's look at the steps needed in order to graph by hand. When we graph by hand, we want to find the real zeros. So that means you factor it and find the zeros of those factors. And you also want to find the y-intercepts. Those are really good points to have in order to get a good graph of your polynomial, because they tell us lots of good information about our function. And often the zeros are useful and the y-intercept is useful when we're interpreting values from our graph. So they're very good things to have. And then, of course, we're going to take those values and actually put them on our graph. So that's step 2. You take your zeros and put them as the x-intercepts, and of course your y-intercept on your y-axis. Then you need a table of values. You pick x values and you get y values. And I always like to look for ones that lie between the real zeros. So in my class, I always tell my students to have at least 1 point in between each pair of zeros, because that's going to give you a really good idea of what your graph is doing. You can have more points than that, but no fewer than that. Then you're going to take those values and put them on your graph. That's step 4. Step 5, end behavior is important, and it doesn't seem extremely important when you're first learning this, but because of how end behavior works, it is important to know what it's doing on the right side and the left side, so you can figure out which way your arrows need to point. And then step 6 is almost like a game of connect the dots. You're connecting all your points together, and you want to make sure you're using curves and not straight lines, because we're doing polynomials, and they have curves, not straight lines. So let's look at an example, and I'll show you how all of these steps work. In example 1, we're asked to graph the function f of x equals x cubed plus 3x squared minus x minus 3. So step 1 is to find the real zeros and the y-intercept of the function. And I gave a hint and I said try factor by grouping. So I'd encourage you to pause this video, try to factor this by grouping, and then hit play to see if you're right. I showed my steps for factor by grouping. I grouped the first 2 terms and the second 2 terms. I factored out an x squared in the first 2 terms and a -1 in the second 2 terms. I factored the GCF, so I had x squared minus 1 times x plus 3. And then the x squared minus 1 could factor further because it's a difference of 2 squares. So I had x minus 1 times x plus 1 times x plus 3. And the zeros of this 0 here is +1, this 0 is -1, and this 0 is -3. Now the y-intercept, just like when we're doing quadratics, it's the plain number in your polynomial, which in my case is -3. So my y-intercept is -3. Let's look at step 2 to our graphing steps. Step 2, I'm just going to put all of this on my graph. So all I did was I took my y-intercept and put it on the y-axis. I took my 3 x-intercepts and I plotted them on my x-axis. And that's step 2. Next, we're moving on to step 3, which is to find more points. When I find more points, I want to find points that are between my zeros. Now notice this pair of zeros already has the y-intercept between it. So I don't need to find another one there. I can if I want, because that'll get me a nicer looking graph, but this is sufficient. And then I notice this other pair of zeros here doesn't have a point in between it. So I think I'm going to put in a -2 into my function and see what I get. And I think that's the only extra value I need, because after this, end behavior will help me with what goes on after these other zeros. So I'm going to take -2 and plug it in. When I put -2 into my function, here's my work, and I got 3 for my answer. So I'm going to plot the point -2 positive 3, which is right here. Now the next step is to use end behavior. So we're going to investigate end behavior. I would encourage you to pause your video here and decide on the end behavior of this, and then hit play to see if you're right. The leading term is positive, and the degree is 3. So the sign is positive and the degree is odd. My end behavior says, as x approaches positive infinity, f of x approaches positive infinity, because the sign on this has to match the sign of my leading term. And as x approaches negative infinity, f of x is going to be negative infinity because it's an odd degree, so the signs on the right here have to be opposites. So what this means for me is that on the right side of my graph, it's pointing up. So I drew this up arrow over here. And on the left side of my graph, it's pointing down. So I drew this down arrow over here. Then I just need to do step 5, which is connect the dots. So on your graph, see if you can connect these dots. When I connected the dots, I got this lovely cubic function. And it has the right shape for a cubic, because I know what a cubic should look like from our first video. And this is the graph of my function. Now we have a few term words we're going to look at, and we're going to do some examples with them. Polynomials tend to have local maxima and minima points, and that is plural. One minimum, one maximum. But if you have it as plural, it's maxima and minima. These are the turning points of your graph. It's where the graph changes direction. And I put a graph over here so you could see it. This actually has 2 local maxima points. Okay, you have this one here and this one here, and 2 local minima. So they are, the local maximum is the point that's higher than all of the surrounding points. It's not the highest point of the graph, because notice this graph goes up forever, so it's never going to have a highest point, but it's higher than all the points around it. And same thing with the local minimum point, is a point that's lower than all of the surrounding points. So this is lower than all of the surrounding points, so this is a local minimum. Now, when you note it, oftentimes we like to highlight the highest value or the lowest value. So we often give the y value, and we say the maximum is maybe 5 when x is 1, and the minimum is maybe like 2 when x is 2, something like that. And you can have as many of these statements as you need. So if you have 2 maximum values, then you can have 2 statements about maximum values. And if you have 2 minimum values, you can have 2 statements about minimum values. And we find those values using a calculator. So I have a separate video about how to find them using a calculator, but we're going to go to a word problem about this and talk about how to build a function for the word problem. And then the calculator is going to give us a final answer. In example 5, it says a welder plans to construct an open box from an 18.5 foot by 24.5 foot sheet of metal by cutting squares from the corners and folding up the sides. Find the maximum volume of the box and the corresponding dimensions. So what I've done is I've drawn a picture over here. It's 18.5 feet long and 24.5 feet wide. And we're cutting out squares from these corners. So I've labeled the measurements on the corners as x. And what we're going to do is we're going to find the volume of this box. And remember, volume is length times width times height. So pause the video, see if you can figure out what those expressions would look like using these x's, and then hit play to check your values. For the volume, I investigated the length, the width, and the height of this box. For the length, I noticed that the total length is 18.5, but I cut out an x here and another x over here. So I did 18.5 minus 2x. For the width, I noticed that this is 24.5 wide, but again, I cut out an x here and another x here. So it's 24.5 minus 2x. And then the height of this is just going to be x, because I'm going to fold these sides up, so the height is going to be x. Now, it's very tempting to multiply this out, and there's nothing wrong with doing it, but they're only asking us for a maximum. So what I can do is plug this right into my calculator and ask it to calculate the maximum value for this. So I would encourage you to watch the next video and do that, and then we'll check those answers when you get to class. Okay? So have a great afternoon. I hope this helped, and let me know if you have any questions.